Hello everyone, welcome back to vishnusmartinfo. This is your track to physics mentor this side, Charusharma, and how are you all doing? I hope you all are doing very good. So in the last video, part 2, we were discussing mechanical properties of solids ka Hooke's law ka graph. In that we discussed about proportional limits and what is elastic behavior, what is plastic behavior, all these points we were discussing. And in the part 1 video we discuss all the terms like tangential stress kya hota hai, what is longitudinal stress, what is longitudinal strain. So all these terms were discussed in part 1 video, and in part 2 we discussed on Hooke's law. So on today's video we will be discussing about some applications of stress and strain, and then and also about the modulus, rigidity modulus we will be discussing. So modulus of elasticity, rigidity modulus, Young's modulus, bulk modulus, all these things we will be discussing in today's video. So in today's video we are discussing modulus of elasticity. Okay, modulus of elasticity. So for in this modulus of elasticity, so this modulus of elasticity is confined to a particular type of object. Like for example, iron will have its own modulus of elasticity. Steel will have a different modulus of elasticity. So like that, it depends upon the types of solid objects you take. So modulus of elasticity are of three types. One is Young's modulus. Young's modulus. The second one is rigidity modulus. Rigidity modulus. And the third one is bulk modulus. Bulk modulus. Okay. So Young's modulus, rigidity modulus, and bulk modulus. Now the bulk modulus is especially used in the case for liquids. Like there will be no Young's modulus for liquids and there will be no rigidity modulus for liquids, but there will be bulk modulus for liquids. Okay, so bulk modulus is very important for like liquids and gases. Bulk modulus will be there, but Young's modulus and rigidity modulus are only for solid objects. Okay, so for Young's modulus, what does, and I told you in the last class only, what does modulus of elasticity means is nothing but the ratio of stress, kind of particular type of stress, particular type, it is a ratio of particular type of stress upon strain, particular type of stress upon strain, or I can say it is a proportionality constant. I can say proportionality constant. Okay, either you can say it is ratio of stress and strain or proportionality constant, okay, between stress and strain. So for this will be modulus of elasticity, either it be Young's modulus, rigidity modulus, bulk modulus. It will not be same for all objects. It will depend from object to object, and the values mostly it will be given in the question, or sometimes they will ask you to find out by giving you force, by giving you area, and by giving you elongation and all these terms. I told you before only what was stress. So as I said, modulus is nothing but ratio of stress upon strain. Before coming to that, let us know first what is stress. I already told you in last class, stress was similar to pressure. It is nothing but force upon unit area. Okay, force upon unit area. And what is strain? What is strain? Strain is change in length, change in dimension, I should say, because when you are considering dimension to be length, you consider change in length. When you consider dimension to be volume, you write change in volume. When you consider dimension to be area, then you consider change in area. So change in dimension upon original dimension. Upon original dimension. That means what, you know? Like for an object, for this particular object, you are applying some force. This force on how much particular area you applied. Due to this force, whatever the change in dimension is occurring upon its original dimensions will be strained. For example, this rod was there. This rod is of length, for example, let us say 10 centimeters. Okay, this rod is there of 10 centimeters. You applied a force of 5 Newton. And the area. So this was the rod of length 10 centimeters. You applied a force of 5 newtons on suppose a area of 2 centimeter square. So area was 2 centimeter square. Okay. So applying this force, what happened? The original length was 10 centimeters. The length increased by 1 centimeter. Okay. So now the new length became 11 centimeters. So how you will define stress over here? Stress will be equal to here force upon area. Force was 5 newtons and area is 2. So stress will be 5 divided by 2. And what will be strain? Strain is change in dimension. Means what was the new length? 11 centimeters. What was the original length? 10 centimeters. So change in length will be 11 minus 10. That is 1 centimeter. So elongation. Instead of change in dimension, I can say elongation. Elongation was by 1 centimeter. So 1 centimeter divided by what was original dimension? 10 centimeters. So 1 divided by 10. So strain will be 1 divided by 10. And stress will be 5 divided by 2. So 5 divided by 2 is nothing but 2.5. And here 1 divided by 10 is nothing but 0.1. So now they will ask what is Young's modulus. What is Young's modulus? Stress upon strain. So what stress ka value got? 2.5. What is strain ka value you got? 0.1. So stress upon strain means 2.5 divided by 0.1. That is nothing but 25. So your Young's modulus value came to be 25 for this rod. Like that you need to find. I hope that is very clear. Okay. So now in detail way, I will tell you about Young's modulus. Then we will go for rigidity modulus. Then we will go for bulk modulus. So coming to Young's modulus. Young's modulus. Okay. So Young's modulus is nothing but longitudinal stress upon longitudinal strain. So stress is nothing but force upon area divided upon strain is change in length, which I denote by delta L, divided upon original length. Okay, so this is your Young's modulus. You denote it with symbol Y. Now coming to rigidity modulus. Okay, so now coming to rigidity modulus. So rigidity modulus you will denote by symbol called eta. Rigidity modulus. Eta, shearing stress divided by shearing strain. Okay, so in part 1 video I already explained you what was shearing stress and what is shearing strain. So for shearing stress, so it is nothing but again force by area only, but for strain it will be theta, because suppose this was your object. The shearing stress or shearing strain will be caused by a tangential force. So tangential force will be like this, F. So what will happen? This upper layer, the upper layer will shift by this much. I will show you with another marker, 1 second. So the upper layer will shift by this much, assume. So the original position of the layer was here. The new position of the layer is here. So if you join the original point to new point, this displacement is x, let us say, and the distance between the two layers is L. So this is your angle theta, right? So how do you denote theta? Theta is equals to opposite upon adjacent, x upon L. So this is what theta over here. I hope you got it. So what is shearing strain? You got it? Okay. So it is it will be caused due to tangential force applied to the upper layer. Okay. Stress is nothing but force by area, similar. So we are done with rigidity modulus. Now let's move to bulk modulus. And I already said you that bulk modulus is especially, it will be there for solids, liquids, gases. But shearing modulus and Young's modulus will be only there for solids, not for liquids and gases. Okay. So bulk modulus denoting with symbol B. So bulk modulus is nothing but volume stress. Volume stress upon volume strain. Volume stress upon volume strain. Volume stress means what? Suppose this was your object. You applied some force on it. Like this force is applied. So what will happen? This object will get compressed. On this much area you applied this force. So this object gets compressed and its volume gets reduced. So volume strain will be what? Change in volume. What was original volume and what was final volume? The final volume will be less, right? Because the object got compressed. As the object got compressed, the final volume will be less and the initial volume was more. So delta V, whatever the change in volume, that will come as negative answer. Why? Because see, let us assume original volume was 10 centimeter cube. And after applying force, it became 8 centimeter cube. And what is the definition for change in dimension? Change in volume strain is equals to change in volume divided by original volume. Change in volume means what? Original. Change in volume means what? Final minus original. Na? Final minus original. Na? This only will denote some change. Na? Like for example, you had initially 100 rupees. Now you have 120 rupees. So what was the change in your amount? Means what? You will say finally I am having 120. Initially I was having 100. So final minus initial, that is 20 rupees ka change you got. Similarly here also, final is 8. Initial was 10. So answer will be coming as minus 2. Means change in volume is negative. Delta V value will come as negative in these cases. Okay. Volume strain will always come as negative. Remember. So volume stress is nothing but force upon area. And volume strain is minus delta V. Why? Because I kept minus, because it will be negative. Divided by original volume. Bulk modulus means you will consider in the terms of volume over here. Okay. This way. I already said you that stress is similar to pressure. Stress is similar to pressure. So instead of F upon A, I can also write pressure divided by minus delta V by V. B, bulk modulus is equals to pressure upon delta V by V. Okay. So pressure you can write as HdG. What is HdG? Height into density into gravity. In liquids ka chapter you will come to know how this is derived. Divided upon minus delta V by V. Okay. Easy. So this you should remember. This is very important equation, that bulk modulus is equals to pressure upon minus delta V by V. And also you should remember the order for bulk modulus, that is bulk modulus of solids. Bulk modulus of solids. Bulk modulus of solids will be greater than bulk modulus of liquids, will be greater than bulk modulus of gases. Okay. And there is one more term called compressibility. So compressibility is nothing but reciprocal of bulk modulus. What does bulk modulus will tell? That once you applied force, how much it is, by how much stress, how much strain is produced. Similarly, compressibility means what? That how much strain was produced by applying how much stress. So it's nothing but inversely proportional. Compressibility is inversely proportional to bulk modulus. So for example, someone asks you what is compressibility, means nothing but strain upon stress. Because bulk modulus was stress upon strain, volume stress upon strain. Compressibility will be strain upon stress, volume strain upon stress. Okay. Easy. So we have already discussed about all the formulas and all the modulus of elasticity over and types of stress and type of strain already discussed. So now we'll move on to applications. Before that, there is one important formula. It's not important to remember the derivation of it, but this formula is very important. In many cases you can easily use this formula and solve your sums. Okay, this formula. So what is Y? Means it is nothing but the relation between Young's modulus, rigidity modulus and bulk modulus. Okay, the relation between all the three modulus is by this equation, that your Young's modulus is equals to 9 times of bulk modulus into rigidity modulus divided by rigidity modulus plus 3 times of bulk modulus. So this is a relation. How did it come? If you learn the derivation, it's very difficult to understand also, and it's none of use. Instead of that, simply remember this formula. It will always help you. Like, they will give you Y and B in the question, and also they will give you force, area, delta L, delta V, all these values, and they will ask you that find n eta. So instead of using this all every concept, if you directly put this formula, it will just take you not even completely 1 minute to solve the sum. So that's why this formula is very important. Try to remember that. Okay. So now let's move on to application, one application which is very important application, and that application will be mostly in the form of question, direct question only it will be there. So how to solve that? They'll not give you any numerical, directly in the formula of, in the type of formula only that question will be there. So that application is like, suppose this was your object. Let me draw properly. So this was your one object. Okay, this was your one object, and it's having an area A. It's having an area A. It's having an area A. So this is your object, and having this is the area of it, circular area of it. Okay. So now what is happening? A force is applied like this, a force on in this direction, like this. In this direction the force is applied. So the force is applied. So what will happen? It will get, suppose this was your original object, like this you assume your original object. Okay, this was your original object, having this was the circular area. Now what happened? You applied a force in this direction. In this direction you applied a force. So this object will get increase in its dimension, and this will be the new area. You applied a tangential force, I mean like this, tangentially you applied a force, or I can say normally, not tangentially, normally you applied the force. So area increased like this. You are understood? This was your original case. Now like this you pulled. So when you pulled, this was a new area. So let us call this area to be A dash. A dash. Now your force was in this direction. Okay. But the normal to this area will be in which direction? This is the normal of the area. Normal means perpendicular to the surface. This is your area considered. So what will be perpendicular line to this? This is a perpendicular line, normal. So whatever the force you applied, assume it is making an angle theta with this normal. Theta with this normal. So this F is in this direction. In this direction, which component you will get? F cos theta. Because with normal it is making theta angle over here, and this perpendicular to this F cos theta, you will get a sine component, that is called F sine theta. Right? Easy. So now if I complete this part as a triangle, if I complete this part as a triangle, Now what I will do, you know, this part, this much area, this part, like zoom, I am doing zoom and magnifying and showing you here. It is just like this triangle. Can you see? It is just like a triangle, no? Okay, which area I am telling? This area. Which line? See, this dotted lines, then this green line, and then this black line. This area, can you see it is a triangle? Okay, this triangle part I have magnified here. So if this angle is theta and this whole angle is 90 and this much part, this whole angle is 90, out of which this much part is theta, then what will be this much part? 90 minus theta. So this angle is 90 minus theta and this is 90 only. So what will be this? Theta. I hope you know how to find that. If this whole angle is 90, this is theta, then this is 90 minus theta in this triangle. In this triangle, this is 90 minus theta. If this is 90 minus theta and this is 90, this will be theta. And you know, in this dimension, in this triangle, this part you can consider as our new area A dash. Our new area is in this direction. Original area was like this. So this is our original area. So how do you find a relation between original area and new area? That will be nothing but cos theta. Cos theta is equals to what? Adjacent by hypotenuse. Adjacent angle, if I consider this is theta, this is opposite side, this is adjacent side. So adjacent by hypotenuse. Hypotenuse is A dash. Hypotenuse is A dash. Okay. So this is the relation that A dash, or I can say A is equals to A dash cos theta. Okay. Easy. I hope you got it. I explained it very clearly. Now coming to what was the stress. So here the stress was longitudinal stress. Longitudinal stress. So longitudinal stress is nothing but force upon area. But you should consider the force which is normal to the area. So this was your area. What is the normal force to this area? F cos theta, na? So F cos theta. Upon area, what is the new area? A dash area. Right? And you know that you can write A dash as A upon cos theta from here. So if I write F cos theta upon A upon cos theta, it becomes F divided by A cos square theta. Right? Cos theta will go up, so it will become cos square theta, means longitudinal stress, what you got? F divided by A cos square theta in this case. Easy? That is clear? Now coming to what was shearing stress. This we found longitudinal stress. For longitudinal stress, the force is always considered which is normal to the area. Okay? And for shearing stress, we will consider the tangential force. Here we are considering normal force. Now we will find what was shearing stress. So in this type of questions, they may ask you two cases. One was longitudinal stress and one is longitudinal stress. One is longitudinal stress and one is shearing stress. So longitudinal stress I explained. Now let's come to shearing stress. Shearing stress. For shearing stress, we should consider tangential force. This is your area. So what is the tangential force? F sin theta, no? F sin theta divided upon area. What is area? A dash. So F sin theta upon A dash. Again A dash you can write it as A upon cos theta. So what it will become? F sin theta, F divided by A sin theta into cos theta. Now what I will do, I will multiply upside by 2 and below also 2. Multiply and divide by 2 and 2. So what it will become? So this, can you see? What is this? 2 sin A cos A. equal to sine 2a. That is a trigonometry formula. So you can write this as 2f sine 2a divided by 2a. So this 2a is nothing but theta. A here I am considering theta. And this A is area. So shearing stress formula you got as 2f sine 2 theta divided by 2a. So when this question is asked in exam, you will completely get confused like how to solve only. But once you listen how the approach is, not the simple approach. First you take the figure and you draw a normal to it. Consider angle theta and now come to know what was the longitudinal force. I mean what was the normal force and what is the tangential force. And now according to the question, if they are asking you longitudinal stress, then take the normal force. If they are asking you shearing stress, take the tangential force and just solve it. This was only the solving part, right? So this formula is also important in this case, that 2f sine 2 theta divided by 2a is your shearing stress in this application. Easy. So this was a very important application, and like I am not only focusing on easy things, because once you learn the hard things, you will always come to know about the simple thing. And the simple thing in this application was just to know which one was tangential force and which one was normal force. And once you decode that, then the sum is very easy. So we are done with this application. Now let's move on to the further part, some more applications like elongation of a wire due to its own weight. Elongation of object or wire, let us say, due to its own weight. Okay. So let us consider this is your wire and the weight of this wire is, the mass of this wire is m, and gravity is acting downwards, so weight will become mg. Okay, weight will become mg. And where is the center of mass lying? Let the whole length be L, length of the wire be L, length of the wire be L. The center of mass will be at a distance L upon 2, L divided by 2. Center of mass, the center of mass will be L divided by 2. So what you will write? Y, Young's modulus is equals to stress upon strain, longitudinal stress upon strain. Stress is nothing but force upon area. Force upon area divided by change in length by original length. So force is what? The own weight, which is mg. What was area over here? Area you can consider as A only, because it will be this circular area, so it will be considered as A only. Now the elongation part, how this is very important, how to understand the elongation, because delta L is nothing but change in length upon elongation, right? So in this question they are asking us to find, I will not confuse you anymore, I will say very simple words, then you will understand. See, in this question they are asking you to find elongation. Elongation is nothing but change in length. This only is elongation. Means this is only they are asking you to find. Now force, so you came to know that was nothing but the wire ka own weight only. Area also we know, this circular area. Now what is the point? This too you should find. Now what is the point is what should be considered as original length. Either it should be the whole length of the wire, or either it should be the just from the end point to the center of mass के बीच में length. That is L divided by 2. So see, stress and strain are related to each other. So by what reason or by what stress that particular strain is produced, you should consider. Now here the strain was produced by mg. The strain was produced by this force mg. So the force here is mg, which is acting at this end point, right? or I must say it is acting on the center of mass. Like it is there is no role of this force acting on some point over here. It is acting from at the center of mass, at the center of mass. So what is the length from the end point to the center of mass? Is L by 2 only, no? Half of the wire distance. So here original length you should consider as L, not complete length of the wire. You should only consider L by 2. So force is mg, area is A only. Let us consider new elongation we need to find, and the length of the wire will be L by 2. I said you why, because you should consider center of mass. So what is the distance between end point and center of mass? Is L by 2. So if you solve this, mg upon A into L by 2 into E. This is nothing but equal to Young's modulus. Now in question they are asking you elongation of wire, means Young modulus is already given. So Young modulus is already given means elongation of wire is equals to, if you solve this, mgl divided by 2ay, mgl divided by 2ay. But see, once if you forget the point, or if you don't understand the concept that why we should only consider this L by 2, because here center of mass is there, that's why we should consider this distance only. If you don't know this concept, what you will take? You will take the original length as L, and you will not get this 2. So your whole sum will get wrong. Understood? That's why this is an important application. Elongation of wire due to its own weight, you should consider up to till center of mass only. L by 2. That is the concept over here. Okay, easy. In similar cases, now this is only due to its own wire ka own weight. Suppose what they will do, elongation of wire they will put, and they will give you the wire. Now to this wire they will attach some more weight, some other weight of mass m, capital M, let us say. That time what is the net elongation they will ask. Means now the elongation of this wire, the change in length of this wire is due to the own mg, small mass, wire ka mass into gravity, this force. Also one more new force is acting, is this next, whatever the new mass you attach to this wire, that capital M into G. That capital M into G. So net elongation E total is equals to net elongation of the wire is equals to its own weight plus elongation of weight, whatever the weight you attach, this weight whatever you attach. So own weight to elongation, now only we found mgl divided by 2ay. But for the new weight, you should not consider L by 2. Now the distance will be whole L length. Why you say whole L length? Because this new mass is attached. For this new mass, the original dimension attaching is this much length of the wire. There is no relation with the center of mass, because this body ka whole mass is towards itself only. Okay, so we know how we got the elongation of its own weight, but now we want to know how to put the elongation due to this new weight mg. So here you should not apply L by 2 or something like that. It is normal concept. What is the normal concept? That elongation is equals to, so here in this formula, see, Young's modulus is equals to stress upon strain. Stress is what? Force upon area. Strain is what? Elongation upon length. So now if you solve this, y is equals to F divided by A into L divided by E. So if E will go here, you will get F L upon A into Y. F L upon A into Y. Can you see it properly? So F L upon A into Y. So this only you should apply. Elongation due to the weight. here you should not, because it's not a concept of elongation due to its own weight. It is a concept of elongation due to whatever the weight you attach. So the original length was L. Now due to this new weight, it will shift by a distance delta L. This is only the elongation. This you need to find. So you will write F force, new force is capital M into G. The force here. The length is original length L. Upon area is A only. And Young's modulus is Y only. So like this. And one more thing I wanted to tell is, what is the use of Young's modulus? More the value of Young's modulus, more the body is elastic. Okay, so you can, by seeing the value of Young's modulus, also you can say the body is elastic, or like more elastic or less elastic. For example, one body A body B. Its Young's modulus value is 16, for example, and here Young's modulus value came to be 17. So which is more elastic? B is more elastic. Okay, so the more the value of Young's modulus, more the body is elastic. Suppose if they give you like the same condition, attaching a weight and the wire, but they gave you this wire is massless, it's not having mass, then what is the elongation of the wire? Then that time you should only consider the elongation due to this weight, not because of anything because of the wire. Okay, so that will be equal to FL upon A. E is your Y, right? FL upon AE is your Y. So elongation is equals to FL upon AY. F is nothing but this, let us consider this bob is of mass M. So force is mg into length of the wire L upon area is A, and Young's modulus Y. Now if they are asking the question in the terms of density, then you know how to relate density and mass. Density is equals to mass upon volume. Okay, so mass is equals to density into volume. Just substitute. Density of this bob here is what? Density D for assuming. And volume is, as it is spherical, it will be 4 by 3 pi r cube. So just substitute that in place of mass. So density into 4 by 3 pi r cube into gravity into L divided by AY. So this is all substituting only. The concept is this. Okay. And in some questions they will ask you, the body is made up of same material. Means what? The Young's modulus is same. Two bodies are there made up of same material. Means Young's modulus is same. Density is same. They will say you same force. Then find the so see. And they will say that two body A and B were there, two objects were there, A and B, both were made up of same material, means their Young's modulus is same, and both were applied same force and area same. So what is the relation between L and E? Means Y is constant, F is constant, A is constant, so L is directly proportional to E, right? This whole term is constant, this is constant, this is constant, so L is directly proportional to E. This you will send this side, no? So L is directly. So if more the length, more is the elongation. Like that, proportionalities they will ask you. Okay. Giving some constant, that same material, if it is given, means consider that Young's modulus for both the bodies is same. So all the important applications were discussed. Now one more thing. See, Y is equals to FL upon AE. I told you, no? That only. If they told you area was constant. Area is constant. If they told you area is constant. If area is constant, then Y, then if area is constant, area is constant. If area is constant, Young's modulus is directly proportional to length. And Young's modulus is inversely proportional to area, or it is inversely proportional to R square, because area I will consider pi R square. Easy? Clear? Now same formula, if they gave you volume is constant. If they gave you volume is constant. Now in this whole formula, nowhere volume is constant. So first to make this formula in terms of volume. Okay. How you will make it means, right, you know that volume is equals to area into length. So in place of area or in place of length, you write V upon A. No, let us let in place of area only. So area is equals to V upon L. So in place of area, substitute V upon L. So Y is equals to F L upon V upon L into E. That means F L square upon VE. Now volume is constant. That means Y is directly proportional to L square. So in question you should read properly. Till now, if we make area constant, Young's modulus is only directly proportional to L. But if you made volume constant, Young's modulus is directly proportional to L square. So read the question properly. What they told you to assume constant. These are nothing but applications only. One simple formula. Y is equals to stress upon strain. So stress is force upon area and strain is elongation upon length. Thus this simple formula, roll and roll. Different things they will ask you to substitute and find. So remember just one simple formula and according to the question you change it. Okay. Now for example, they will ask you to assume that volume is constant but length is not given. Volume was constant but length was not given in the question. See, till now I asked you to assume now that Y is equals to FL square upon A VE. In this formula, length was given in the question. Suppose volume is constant and length is not mentioned in question. Length is not mentioned. That time what you should do, you know, that Y is okay, can you see? Y is equals to F upon A E L. This, no? Now volume is equals to area into length. Now till now we substituted in term of area. Now you should substitute in place of length. So length is equals to V upon A. So that is equals to F into V upon A square it will become, because this A multiplied with this A into E. So now volume was constant and length is not mentioned. That time you should write in terms of area. That time Young's modulus is inversely proportional to A square. Young's modulus is inversely proportional to A square or inversely proportional to R to the power 4. Why R to the power 4? Because area is equals to pi R square. Area is only directly proportional to R square. And here this is A square. So this will become whole square to here. Okay. I hope you understood this application, that volume is constant and length is not mentioned. Please ignore that sound. That is clock sound. Okay. So this is very easy. I hope you got all the applications. So we are done with all the applications. Now what we are left is thermal stress, wires in series combination, wires in parallel combination, and we are left with potential energy. So only these 3 topics left. And I have seen that on part 2 video there were like so less views, just only 80 to 90. Why is it so? Why you all are not watching the lesson or not liking it? Please let me know in the comment section what I need to change. Okay, so please support, like the video, share to your friends, and be in the live premiering session. That time you will understand more clearly. If you can see the videos 2 to 3 times. Okay, and I'm planning some more things, but that will take time to be launched. Till then you should be focused at what I am telling. So now your homework for today is read NCERT of mechanical properties of solids up till wherever I taught all these applications, and do NCERT problems, solve the questions from your modules, and try to give your best. Don't ignore the lessons. Okay, because every single concept, every single point is important in your preparation journey. So that's it for today. Like the video, just one like will let me know, and please put some comment in below, like are you liking the video or not. At least some support you should put. Okay, that's it. Thank you for today's class. It was good having you all here. Thank you very much. Bye bye. Tata. See you.